So hey guys, we have landed at our analysis part now, and here on I will be briefing you about the analysis. For that, I will not be I will be explaining this particular analysis part in bits and pieces. I will not be providing you lots of details of why I am using these functions over here, what is the purpose of using these functions. You can get the reason for using this particular function, where I am using this particular dot read csv dot head function. These are the small things which you guys can explore it from the internet there itself. Okay, so for that, before starting off, I will be briefing you about my dataset. This is my dataset. In the first column, we have the match number, the number of matches played in the T20 World Cup series, and second, we have the date. The date was Saturday, June 1, 2024. Okay, the venue was Grand Prix Stadium, Dallas. The first team to play was Canada, and the second team to play was United States of America. Stage Group A, toss winning. The toss was won by United States of America, and the toss decision was for the fielding. The first inning, the score was 194, and the fall of wickets was 5. And for the second innings, the score was 197, for the fall of wickets 3. The winners were United States of America, and the method was a normal match, and it was won by wickets. And if you talk about the winning margin was 7, and the top scorer was Aaron Jones, and the highest scorer was 94. 94, yeah. So similarly, we have the best bowler figure, runs received, player of the match, and so on. So I will not be briefing you a lot about this particular dataset. I will be uploading this particular dataset into the Google Drive, and I will provide the link there itself at the description below. You guys can uh, have a look over this particular dataset, or you can download it and use it for your analysis task. So I have mounted my Google Drive over here. This is the piece of code. This is a code snippet or the syntax for mounting the Google Drive into your Google Collaborator. And these are the necessary, what do you say, necessary libraries which I am using for my analysis. Pandas, this is a common library used for data dealing with the dataset. NumPy is used for what is that, working with arrays and all. And Matplot, Plotly, you guys can get what is the reason for using these libraries later on. So I have created a data frame. Name of my data frame was creek underscore dataset, and I am reading my dataset file, or the ICC main T20 World Cup .csv file over my data frame, that is creek underscore dataset. If you visualize my data frame, this is my data frame where all the data set all the datas of the data set were stored: match number, date, venue, first team, second team, so on. Greek underscore dataset dot zip. So this is the block of code will provide me the dimensity or the dimension of my particular dataset. So I have 55 rows and 22 columns in my dataset. Okay. Now moving on, click underscore data set is null. So this dot sum. So this particular line of code will show me is there any null value in my data set. If it is there, then it will be giving me NaN. Present in the click underscore data types. It will provide me the data types of this particular columns. So for the match number, we have object yes. For the date, we have object yes. For the venue, objects, first team object, second team object, stage was group A. Toss winning object, it was won by United States of America. Toss decision was for the fielding, it was object type yes. So what basically object type is, in Python, the string values were considered to be object type. And the fall of wickets first inning. Oh, hold on. So the first inning score it's showing object, okay, but it was not. If you look at the data frame, the first inning score was 194. It is a numerical value, brother. It is not a floating type, or it is not a string type. But here on it shows it's an object. It is taking it as a string type data, but it is not. We will rectify that. For that, I have done a change object data columns that are actually integer. So for that, I am dropping all the columns containing the numerical data or the integer values. Okay, for that I have dropped first inning score, fall of wickets, all the columns. Okay, now this is the new data frame where I am dropping all of these and only storing the columns having the string values. If you visualize this particular data frame, this is my data frame where all of the columns having numerical data were being dropped, and only the columns having the string values were kept in this particular data frame, that is categorical underscore data frame. Remember this particular data frame name. I will be explaining a little bit of this particular data frame later on. The wrong type, using the wrong type data, we will be using a wrong type data frame. We will be using a wrong type data frame where we will be storing the columns which are having the numerical data. And you can see these are the numerical data columns I have stored in wrong data type. Also remember this particular name of the data frame. Now what I am doing here is I am converting the data type of the wrong data type frame where my first innings score, fall of wickets, first innings, second innings score, fall of wickets in second innings. So these are the numerical data, but I am converting the data type for that particular columns which contains the numerical data, because it was showing earlier, it was showing object data type, right? So for that we will do a process that we will do a apply method pd.numeric. We will convert it. Now if we visualize the numeric data frame dot data types, this is the data, this is the data frame. I am converting it and storing it in numeric data frame. So this I am taking a numeric data frame where I am I am taking another numeric underscore data underscore frame. This is another data frame where I will be converting the object data types into the numerical data type or the floating point data types. Then I will apply it and I will store it. I will be storing it in numeric underscore data underscore this particular frame data frame. Okay. So if you visualize the data types of this particular data frame, the first inning score was float type data, and the fall of wickets were floating point data, and the second inning so on so. So these data types were previously showing me object, now it's showing me float 64 because I have already converted them into floating point variables. Now if you describe this particular data frame, these are the description of this particular data frame: winning margin, fall of wickets, so and so. If you visualize this particular data frame, we have first inning score 194. Yeah, these are all the floating point variables I have already converted. Now what we will be doing, because I have already separated, I have previously I have dropped the columns having the numerical data. I have completely separated them, and also the columns having the string values, I have already separated them into a new data frame. Now we will concat them in order to get the whole data set. For that, I am taking another data frame, creek underscore data frame, where I am concatenating the categorical data frame which contains the columns having the string values along with the numerical data frame. This is my numerical data frame where the columns having the numerical data, the floating point data variables, into a single data frame. I'm concatenating this categorical data frame and the numerical data frame into a single data frame, that is called Greek underscore data frame. Understood? Now if you visualize them, visualize this particular data frame, the number of matches, date. In the first order we have all the string type data, and the second order we have, from the second order we have, this is the numerical, sorry, this is the floating point data. These are the numerical data. Now what, for the information we will be checking, is there any null value, because being a coder we understand if we miss out something there will be a null value. For that, for the checking, for the safer side, safer ground, to be in a safer ground, we will be checking is there any null value present in our data after concatenating them. So Greek underscore data frame dot data types, where we will be looking at the data types of our new concatenated data frame, that is the match number. Yeah, all of these string values are showing the object type, and all of these numerical values were showing the floating point data types. Okay, from the first innings to next 12 figures. Okay, so cool. We have done our most of the basic parts, and these are now our main analysis part starts here. For the venue according to matches, we have taken a variable venue where we have grouped by the venue and the matches. Okay, for that it we have the venue, these are the venue and these are the matches played in this particular venue. For a proper visualization of this particular piece of data, I have used the histogram method. That I have created this particular histogram where we can clearly see the venue was Kensington Oval, Bridgetown, Barbados, where the maximum matches were played, that is 9 matches were played in this particular venue. And secondly, we have uh, Nassau County International Cricket Stadium, New York, and also C. Vivian Richards Stadium, North Sound, Antigua. Both of them were the second maximum occurrences of matches. If you look at our interpretation, we can see the venue that played most is Kensington Oval. This one, Kensington Oval, Bristol Barbados. And the second played venue is jointly was Nassau County International Cricket Stadium and the Sir Vivian Richards Stadium, North Sound, Antigua. Both are played 8 times in their venue. And similarly, third, Providence Stadium and Terence Sammy National Cricket Stadium. Okay. Now, second analysis, we have match win based on toss win. For that, we have grouped by the toss decision and the winners. This is the particular data. For visualizing this particular data, I have used a pie chart. And if you see, 76.4% toss decision was for fielding and the win ratio was 42. And 18.2% toss decision was for the batting and the win ratio was 10. 5.45% the toss decision was a rain. It was not a toss decision actually, so it was okay. Let's look at the interpretation and we'll understand it. We can see that after 76.4% of the match win whom first choice was fielding after tossing, and 18.2% of the match win whom first choice was batting for after tossing, and 5.45% of total match was abandoned, and some of them win by DLS method. Okay, you understood, right? So now the third analysis we have, that is distribution of first inning score. We have taken the column first inning score and the second inning score column. This is providing the particular data, and if you plot the graph, we have distribution of first inning score. First inning score was ranging between 100 to 119 and the count was 12. Okay. Then secondly, we have first inning score was 140 to 159. The count was 9. If you look at the interpretation, it says we can see that the 12 matches first inning score were ranging between 100 to 119, and the 9 matches first inning score were in range of 140 to 159. The 9 matches first inning score were 180 to 199, 180 to 199. Sorry, this was 7. Uh, my bad. 7. Okay. Now, our fourth analysis is distribution of second inning score. If you look at the graph of the second inning score, the second inning score was ranging between 100 to 119, and the count was 70. Interpretation say we can see that the 17 matches second inning score were in range of 100 to 119, and the 9 matches second inning score were in the range of 120 to 139. It was I think 12 matches, so 17 matches. Okay. Now the fifth analysis, we have best bowling figure in single match. Bowler equals to cricket underscore data frame. So we are taking the best bowler column, best bowler figure, wicket second, best bowler figures, runs, but actually there is certain inconvenience in the data. I have already mentioned here, that is, in this data set we find error in best bowler figure, wicket second columns. Not working Jing got 30 wicket and Alpesh Ramjani got 17 wickets in a single match. That is not a valid data, so we should avoid them. For the best bowler figures, we have taken the wickets taken, and we can see this particular data. If we visualize it, if we use it in use a bar graph, we will understand it clearly. Best bowler figure variable was best bowler figure wickets taken, Akil Hossain and Fazal Haq Faruqi, and for the best bowler figure runs received, Gulbadin Naib, and secondly Tarbraiz Samsi. For the sixth best batter run figure in the single match, we are taking top scorer and highest scorer. This is the particular data. If you visualize it, you can see the top scorer, and this is the y-axis. We are looking at the top scorer, and the x-axis we are looking at the highest scorer. For that, Nicholas Poran was the highest in this. And if you look at the player, if you analyze the player of the match got from the tournament, we will be taking the player of the match column, and we will be doing certain analysis part. This is the particular data. If you visualize it. Okay, so before going to that, this player of the match count, it is showing rain, so rain is not considered as a player of match generally. For that, we will be rectifying our data frame. We will be removing the rain. If we see the player of the match, count was 3. 3 times player of the match, Fazal Haq Faruqi. Okay. If we're plotting a graph, it shows top 5 player with player of the match award. Fazal Faruqi got, what is that? 3 count. Okay. 3 times he got the player of the match. Similarly, we have our this is the very proud moment. We have our Jasprit Bumrah, the player of the match in the section of top 5 player of the match, and becoming 2 times the player of the match. So that's basically all about the analysis I have done particularly, and